Okay, so this is just a short podcast to end our study of object-oriented Python programming, and I really just want to look at something called inheritance. So why do we use classes and objects in Python? There are a number of different reasons, one of which is just to objects allow a better modeling of the system. So if we're trying to write a system to record student results or what modules they take, rather than use some of the Python programming language techniques, it might be better to use objects to represent the student. So this is a much better way to make the code a bit more like the system we're trying to represent. So one of the key ideas of objects is that the information is hidden from the user of the object, and this is sometimes known as encapsulation or information hiding. So in this example below, so here we have a class of rectangle, and it stores the height and width of the rectangle. So this init thing is called the constructor. We saw this example last time. So we have this thing here, r equals rectangle 1, 2. It passes in the width and the height of the rectangle, stores it in this self thing, self.xx, stores the height and the width. And then later on we can do calculations with it, like compute the area. So the area of a rectangle is the height times the width. And we store that in self.x and self.y. And the reason why you do this is because if you're doing like some analysis of shapes, then you've hidden all the functionality of the rectangle in the object, and when you're using the objects, you just have to call r equals rectangle to create a rectangle. Then if you want to find the area, you use this thing. And then like in the last one, if you want to define like the perimeter, the size of the perimeter of the rectangle, you can write a method of that. So the idea of object-oriented analysis is you work with objects, and then you call methods to calculate stuff. So we discussed that last time, last lecture. So the idea of object-oriented programming is we have a library of objects that interact via methods. But then the issue comes in how to extend the classes. So what do I mean by this? So if we're writing software for the university and we're trying to sort of, if we're writing like something for the, to look at the salaries or look what people's doing, we might want to have classes for lecturers, professors, technicians, administrative staffs. And then some of these objects will share bits of code, like every one of these things will have a name and they'll probably have a staff number. But then some of these objects, like the lecturers and professors, will do teaching, whereas the technicians and the administrative staff may do no teaching. And so somehow you want an efficient way of sharing code. So some parts of the lecturers and professors share functionality with technicians and administrative staff, but then there are some things that are different. And this is what sort of inheritance it does. It builds upon objects. Okay, so it's all very abstract. So the simple example I'm going to look at is the rectangle class we had again. So we already have an example, some code we saw before, how to compute a rectangle. So we input the height and the width, and then we can compute the area. But then maybe if we were on a color system, we want to introduce a colored rectangle. And we already have code to compute the area, but now we have to take into account the fact that the rectangle is colored. So we need to somehow extend the class to create something called color rectangle, and all it does in this simple example is just record the color. So this is what the code looks like. We have code class rectangle. This is like the same code we had before. It records the height and the width, stores it internally in self.x equals x, self.y, compute the area. Then this class color rectangle, inheritance from rectangle. So we have color rectangle, and we see here it takes the argument rectangle in the class definition. And what this means is we're adding functionality to color rectangle. So color rectangle contains everything that rectangle does and adds some additional functionality. In this case, you just want to record the name of the color. So here def underscore init is the constructor. This is called when we call color rectangle down here. So with this color rectangle, all we're doing is adding functionality of storing the name of the color. And the way this is done is we have a new constructor. This super command means it calls the constructor of the parent class init. So when I call super.init, because there's a rectangle here, it calls this function here, and this is what puts the height and the width in. So the idea of color rectangle, it stores information about the height and the width, and it also stores the color. And so the idea is to extend the idea of a rectangle to add in the idea of color. And this is a common thing in object analysis called inheritance, where we have an object and we want to extend the functionality. So now when we call rectangle equals color rectangle, it calls the constructor, this thing here. It takes the height and the width. Now it takes the color. And color rectangle now, because it inherits a rectangle, it can compute. It still has the functionality area from this thing, from the rectangle object, because it inherits everything. And also it now also contains the color. So by designing this new object, color rectangle, we've extended the functionality to have a color, and we've had the height and width. So we now have an object which will store color rectangle, but it can still compute the error. So that's sort of the idea of inheritance. Okay, so in the jargon of this thing, the rectangle is the parent class, and the color rectangle is the child class. As I say, the key thing of this is this super object returns the returns a proxy object of the superclass of color rectangle is rectangle. And so this is just a fancy way of saying, well, before here, when I want to access methods or things from the parent class, here I want to call the constructor of the rectangle, and I call super dot. And this means when I see super dot, it calls something in the rectangle class. And that's how you access the lower things. So, I mean, the key idea of inheritance is you have some code and you want to add some functionality, you want to build on top of it. And that's the idea of inheritance. Just a bit more information for you. So in Python, so here we had an example of, previous example, we had a color rectangle inheriting from a rectangle class. But actually, in Python, there is something called the object class, which is the sort of base class which everything inherits from. And the object class is essentially an empty object. And the object is the base for all classes. And it sort of defines the basic properties and methods which default for all classes. So here's my example. Here is just so this x equals object is like an empty object. And when I run here type of x, type x, it tells me that the object is it tells me the type is object. There's also this fancy function called dir, which when I apply to the object x, creatable object, it tells me all the methods that it has. So this empty object has methods already predefined. So I think in the jargon, this is something called reflection. And so actually, when you create a simple class, you're actually already inheriting all this from this object. So in Python 3, actually this class simple here, I have the constructor. Here when I have class simple A, and I explicitly put in the inheritance of the object. And all this object, these two things are doing is just storing the number. So remember here, if I do A equals simple 10, that just means it calls this, goes to class simple, calls the constructor, stores 10. And I do the same if B equals simple A, This one, it stores simple A object and stores number 5. And just the way that the kind of Python works, even if you don't say you're inheriting from the object, Python 3 assumes you're inheriting from the object, and that means that when you do dir, you look at it, you have all these additional methods. So in some sense, there's this base object, and then whenever you define a class, it builds upon those. Okay, so I really explained to you just basically some of the idea of inheritance, because if we could do object-oriented programming, you need to know a little bit about it. However, I'd recommend actually not really using inheritance in your code. It's important to know about it because it's used, but you have to be a bit careful when you use it. It's often used to use something called composition rather than inheritance. There's some discussion of these things here, and yeah, I mean it's something that sounds like a good idea when once you get your head around it, but actually in practice it's kind of quite hard to use correctly. In the example here, we have something where we can inherit. Here we have our example where we have a color rectangle. We're inheriting stuff from rectangle. You can inherit from multiple objects, from multiple classes, and that's called multiple inheritance, which is possible, but it's sort of also recommended not to do that because it just makes the code a bit of a mess. So I say it is important to know about inheritance because you'll quite often see codes that use it, and it's quite important to know things like actually the integers and numbers are actually objects and they're inherited from this base object. And in fact, a long time ago I did write a C++ code to do statistical analysis, and I used multiple inheritance to sort of model the way the data flowed through the into the C++ code, and frankly that ended up a complete mess in the end, and partly because I was trying to cram the kind of data analysis into this inheritance framework, and it wasn't a natural fit. So it's important to know about it, but there are kind of patterns of uses that people say, and so I'd be very nervous about using it in your own code. But it is useful to know about, partly because you'll see other people using it. There's a discussion of, if you want to learn more about it, there's a discussion of inheritance in the book Think Python, which is at this link here. And there's also a discussion on the W3 schools page on inheritance there. So it's worth knowing a little bit about.